Hey guys, how are you doing? So let's solve a new probability question today. What do we have here? We have n balls are drawn without replacement from an urn containing capital N greater than n balls. Okay, so our urn has total number of capital N balls, and we have to select small n balls without replacement, which are numbered from 1 to n. What is the expected value of the largest number drawn? So I've told you already that whenever expected value questions come, we think using indicator random variable or our usual method, usual formula which we use, that is the score into the probability of getting that score, summation of that, something like that. So we have to decide which of these is best for a given question. So indicator random variable is best for those type of question in which we have to find number of something, right? Number of certain value, uh, like let's say number of loops, when we join free ends of wires, something like that. Getting my point? But in this case we are asked to find the largest number which will be drawn. Largest number cannot be represented as the sum of certain type of RVs, right? The largest number cannot be written as the sum of certain type of indicator random variables, which will make our work easy, and hence the, we need to think in the usual direction. Okay, so what does the usual formula say? It says that, let's say x is the largest number drawn. It may be drawn by any person, let's say anyone among the n balls. So how many balls are left? Balls left is n minus 1. Values left are x minus 1. Among the x minus 1 values, as we are selecting without replacement and each ball has number 1 to n, all of them have different values. So there are x minus 1 values left, and we have to select n minus 1 balls. So what is the number of way to do that? X minus 1 c n minus 1, right? And what is the total probability? Total probability is we select capital N, we select sorry among capital N balls we select n balls, ncn, right? Now if our score is x, that is the largest number is x, then multiplying x and then summing x from n to x equal to, what will be the maximum value? How much can we go? X can be at max n, right? We can go till n. So we need to find out the summation of this value. So the summation of this value seems kind of tough, right? Let's make it easier by removing this dependency of x over here. This is causing some issues, right? So if we write this, it will be x minus 1 factorial divided by n minus x factorial divided into n minus 1 factorial, right? And x is multiplied. So let's say we multiply x over here, and we also by multiply n over here and n over here. Okay, so now what we have, n into x factorial divided by n factorial into n minus x factorial. Can we write this as n into x cn? Yes, we can. Plus we have removed the x factor. Now n is a constant, so we have no issues in carrying out this n, right? So n into x cn by, and we can also take common the n choose n, capital N choose small n. So basically this is what we are left with, our summation, capital N choose n into summation of x equal to small n to n capital N. We have x cn, the summation of this, right? So x cn can be written as also, if we put the values, it is n cn plus n plus 1 cn plus n plus 2 cn plus dot 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 capital N cn, right? This is it. This is that. This is this. Okay, fine. I'll increase the size of the page a bit more, because it is a bit disturbing when when the page ends and I have to compromise on the size of the solution. You get my point, I guess. Anyways, I guess this is enough for now. So now we have to, so basically let's find the summation. Forget about these, we'll be just putting the value afterwards in this. Okay, so we have the summation as ncn plus n plus 1 cn plus dot 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 capital N cn, right? We can also write this as nc0 plus n plus 1 c1 plus dot 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 ncn minus n, right? This is fine. Now this is a formula. If you know, it's great, but I don't think you know the formula, so let's derive the formula. So let's say nc0 plus n plus 1 c, I'm adding n plus 1 c0 and subtracting n plus 1 c0. Okay, ncn minus n, and I'm subtracting n plus 1 c0 as I added it over here, right? That's fine, I guess. So nc0 plus also there is this formula in a recursive formula for n minus 1 cr. Have you seen this formula? Have you ever seen this formula? This formula is basically the recursive formula we can use to find out NCR. This is a recursive formula. You can prove this by just simplifying this, and it's pretty much easy to prove. So this is one one result which we'll use for here. So you can see, and if we put n plus 1 and 0 1 over here, then this gives us n plus 2 c1, right? You can see very clearly. So nc0 plus n plus 2 c1 plus n plus 2 c2 is there, dot 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 ncn minus n, this is there, and finally our n plus 1 c0 is obviously there. Okay, now what will this give? This will give n plus 3 c2, right? And again there is n plus 3 c3 originally in the summation, and so on. So you will see that finally our sum will be like, finally it will be nc0 plus ncn minus n minus 1 plus ncn minus n. Now when we sum this, and there is this minus n plus 1 c0 carrying over. Okay, and I guess we can cancel these two out, because n plus 1 c0 is also 1 and c0 is also 1, so we have no issues. And when we find the formula for this, it will be n plus 1 c, again we apply the same recursive formula, that is ncr equal to n minus 1 cr minus 1 plus n minus 1 cr, and it will give us n plus 1 cn minus n. Okay, which is equal to basically if we see n plus 1 c n plus 1. Okay, this is it. So this is the final summation value which we get, n plus 1 c n plus 1. Okay, so where did we leave our, so n by ncn into n plus 1 c n plus 1. So let's simplify this a bit. It was n into n plus 1 factorial divided by n minus n factorial into n plus 1 factorial divided by ncn is n factorial divided by n minus n factorial into n factorial, right? So n factor plus 1, this is n plus 1, this totally gets cancelled out, this gets n plus 1. So our final value turns out to be n into n plus 1 by n plus 1. So this is the expected value of the largest number which we get if we select n balls among capital N balls. So most of it was combinatorics and combination formula and algebraic expressions and algebra. So that is fine. You don't need to worry about the algebra. You know how it is done, and now you can do it. That is not our main concern. Our main concern was to get till this formula, and then it was all about the algebra. So we lost probability at this self itself. It was probability till this point, and after that it's just combinatorics all over. So I hope you like this question. It's a good question. If we see algebraic, if you want to check the person's algebra skills too, I hope you like the video. If you liked it, please share it with your friends, and yeah, that's it.